So as I was saying, um, the logic of this is you're going to divide data into three parts. Now, for you to do that, you have to locate the middle number. Now, if you divide into two number, the middle number, if it's 1, then sorry, I mean that if the number at the middle data rather, I don't know the number, the middle data is located and you're able to divide the two other sections, that's the number set of number below the middle number and the set of number above the middle number. If they are they must be balanced. So now this one, what they did, they divide this into 2. So because the total number is 16, so the middle number will be 2. So position, which is they will be in the position 8 and the position 9th data. So when you look for the average of the two middle number, you have your median, and that will give you the middle number. And the middle number here is 7. So it's the average of 7 and 7 that gives you 7. Not just one 7 was picked. So that's what I'm trying to explain that to you. However, if the data here is 15 number, it will be obvious that on the 8th number, or 8th position of the data, you're going to have 7. That will also be correct. But in this case, 8 and 9 was added together and divided. The average of that was gotten. Now, what I was trying to explain the other time to you in the previous video was that when you have divided the two into two groups like that, you look for the median or the first part. That's why I said you have to arrange it in the ascending. This is the first part, and that is just written here of this data. So the middle number here should be 5 and 7, right? Because distribution is even distribution is 8, so you can't have one number in the middle. So you're going to have two numbers in the middle, and the two numbers is 5 and 7. So when you look for the average of this 5 and 7, you are going to get 6 Q1. So that will be your Q1. So the average of 5 and 7, look at what they say there, is going to be 6. Now let's go to the other side. Look at the set of number above the middle number, which is 7 here. Now, and that is 7, 7, 8. This is distribution data above Q2, and that will be, so you look for the middle number too, look for the median of this set of the other part too, and if you do that, you're going to have 1, 2, 3, 4. This is the fourth one. There are 8. The total number is 8, so 4, 5. So the fourth and the fifth one will be in the middle, right? So that will be 8 and 9. So when you add the two together, 8 plus 9 divided by 2, that will give you a Q3 is 8.5. So please just listen. What I'm saying, I know it's technical, because now let me give an example. So that will give you 8.5, and that will be your Q3. So we now have our Q1 to be 6, Q2 to be the middle number, and Q3 to be 8.5. Now I want to make it more clear. Now let's say when we divide the two groups, let's say we have this long data. Let's say instead of 16 number, like I said, you have 15 number. You just have to count what's the half of 15. That will be 7.5, so when you count yourself, 1, 2, 3, 4, 5, 6, 7, you know that this 7 will just be there, and the next number will be the middle number, and you go on. But because this one is 16 number, 16, so the half of 7 of 16 is going to be 8. So, and it's going to be even, so it's balanced. I'm repeating this because it's very important. That can confuse you. So we have the same thing apply to this case too. So you can have your median to be 1, or you can have your median to be 2 numbers. So if it's 2 numbers, you divide it by 2. The 2 number in the middle. That's what I'm saying. Okay, let me move on to the next thing. Okay, let me use this as an example. Okay, I've done the example already. So according to that, so your Q1 is 6, which is the median of the first group below the middle number. Your Q3 is the median of the second group above your the middle number. Now, the reason I said above is because the average of how we were able to get our Q2 was the average of the two middle number. So we are so lucky that is 7. It could be another thing. So you just have to count it that way. You just have to see it that way. You understand? Let me move on. What other thing now to talk about? Okay, percentile are mostly used for very large list of numerical data ordered from least to greatest. Instead of dividing the data into 4 groups, 99 percentile. So this percentile is somehow similar to the quartile, this first quarter, second quarter, and third quarter that we just talked about now. You understand? Similar. But let's see how it goes. So Q1 is P25. So when you're using percentile instead of Q1, so P25 means like the first 25 values or the first 25 percentage of the distribution. Everything must be 99 percentile. Everything, the data. Now Q1 is the same as P25, which is the first 25 percentile. M is equals to Q2 equals to P50. P50 like the middle number like the average. So that's the 50%, that's half, the middle number. Now, so that's the P50, 50 percentile, the 50%, that's the meaning of that. And the Q3 is going to be P75, that will be 75 percentile in a distribution. Percentile means 100, so the total percentage is 100. So you're just talking about how it is divided along. So it's divided to 3, P25, P50, P75. You have to just know that in your brain. You have to cram it like that. So Q1 is P25, Q2 is P50, and Q3 is P75. But what they do here is just adding 25 to it. The first one is 25, add 25, make it P50, add another 25, make it P75. So that's just still the same thing. So you can use the interchange. You can interchange the way you use them. The Q and the percentile, the quarter and the percentile is all the same. Okay. Let me talk about dispersion. Now, when you're talking about dispersion, measures of dispersion indicate the degree of spread of data. The most common statistics are used to measure the dispersion are the range, interquartile range, and the standard deviation. Now, this is very important. Now, talking about the range of the distribution, when you're talking about the range of distribution, you're talking about how dispersed it is. Now, the range of distribution, the formula is just G, which is the greatest data, minus the least data. That's all. There's no range of the greatest minus the lowest. So, if I'm going to be using a distribution, let's say I'm using this distribution, the greatest number here will be 21, right? That's 21 minus the lowest number here is going to be 5. That's 16. So I always tell you're talking about anything like that. Arrange this first from lowest to greatest. And this is what I did here. 5, 10, 11, 20, 21. This is the same data. So arrange it that way. And it will be easy for you to pick out. So the range will be 16. So that's just the formula. Range, greatest minus lowest. That's the same thing they did here. I just have to show you the other screen. Another thing you need to know about outliners. Outliners are some figure that will just be too unnecessarily big. It's obvious that it's not part of the distribution. It can be removed so that it can give you more accuracy. You understand? For example, in this distribution now, you just see after 21, you just see 100. Let's say another data is added. You now see 100. You should know that 100 is an outliner. It's too much. It's not in the scope of this, so we remove it so that it will not affect your result. But since the range is greatest minus lowest, so that would now be 100 minus 5. So that will be too much, so it's going to affect you. Now, another thing you need to, all this formula, you need to write it down and use it to practice so that you can have it in your memory. And that is the interquartile range. Interquartile range is the formula for it is Q3 minus Q1. I'll give you interquartile range. And thank God you now know how to get your Q3 and Q1. So you're going to, in your data, you have to get your Q1. That was the explanation I made the other time. And I'm talking about Q1. For example, now, this data, when you divide it into 2, the lower set of numbers, you look for the median. That's what they did here. And they got their Q1 to be 6. Then the other part, which is higher than the middle number, which is 10, is the other set of number, this number, look for the median of the set of number 2, you get your 8.5. That's your Q3. So you're supposed to look for the interquartile range of this data now. So particularly how it's going to be, that's going to be Q3 8.5 minus 6. That will give you an, which is Q, and Q3 minus Q, and that will be 8.5 minus 6. So I just need to show you that. So that's the same thing I'm talking about here. So the other range measures the spread of middle half theta. So very important to note that. And let's say this distribution, like I showed you the other time, is the same thing. When you divide this data into 2, you arrange from the lowest to the highest first, then divide the data into 2 half. So the first part is you look for the median of the first part, you get your 6, you get 6, median of the other part above the middle number, you get 8.5. So this example is the same example I just showed you up here. Yeah, this one I just talked about. So please, I think you should understand that clearly. Don't worry. We'll also solve a lot of questions later, but I believe you should understand with this little explanation I've done for you. Now, this is the practical, what will I call it now? You must learn this. It's very, very important, because there are some question that is written like this. Now, this your Q1, Q2, Q3 can be represented on graph. Your quarter can be represented on graph. Sorry, yeah. This is a graph. Can you call this a box? Call it box plots. We skip both plots. For example, now, if it's drawn like this is the lowest point. This is the scalar. Each also is the greatest, and then followed by Q3, which is the third quarter, followed by M, which is the middle number, and Q1, which is the first quarter. Now, according to this table now, it's obvious that the greatest number is 9, the Q3 will be around 8.5, the middle number, which is your Q2, is 7, and Q1 is 6, and the lowest number is 2. So what you see here is what this question was plotted. Yeah, our Q1 is 6, that's it here. Our Q3 is 8.5, that's what we have here. Then the middle number is 7. The number they did here, the example they showed us here was plotted down here. So this is it's plotted. It's represented on the box plot. Now, this L is the lowest number in the distribution. That's 2. And G is the greatest number, that is 9. So please, they can set question using this diagram for you. You must learn to understand this. So that's how. So let me do an example. Let me show you some example here. Now, these two, list 1 and list 2 is plotted like this on the same scale. Now, here is the greatest number. That's around, I'm not sure, let me look down. That would be like around 750. Your Q3, this is the Q3, that's around 700. It will be the middle number, that will be around 450. Then this is going to be your Q1, that will be around 290 or 280. I'm not sure. Should be accurate when you trace it down scale. Then this one will be the L1, the lowest point, L, that will be 200. So the same thing happens to this, the lower one here. The greatest number here is going to be 750 or so. This is your Q3, 600, middle number around 550. I'm not sure, but when you trace it down, this will be your Q1. That will be 380 or 390. Then this is the lowest number, that is 250. So that's what we're talking about here. Basically, we're comparing the two scales together. When you read it, you get to understand better stuff like that. So they were saying, based on the the plot. I will explain this in the next video. Thank you.